Hey everybody, this is the guided practice video for week 11.3. This is section 11.4 in your text. Quadratic forms are sometimes called quadratic type equations. And the reason that they're called quadratic type equations is they're not exactly quadratic, but they behave quadratic, which means that we can use quadratic solving techniques like completing the square or factoring, or what's most commonly used is the quadratic formula. So let's take a look at this idea. An equation is quadratic in form if it can be rewritten as a times something squared plus b times something specifically to the first power plus c is equal to 0. So it has that quadratic form. But what you'll notice down here in this first example, x to the fourth minus 9x squared plus 20 equals 0, is it's not quadratic because it's got a fourth power. So what we're going to do is we're going to write it in standard form. Now, ideally what we want to do is we want to write this as a plus something squared times b plus something to the first power plus c, I guess, is equal to 0. And we can do that here if we rewrite x to the fourth as x squared squared minus 9 times x squared to the first power plus 20 equals 0. So what's going on here is, even though it's not quadratic, it's quadratic type if I treat the variable not as x but as x squared. So typically what we do at this point, if we have a hard time recognizing that as being quadratic, is use what's called a substitution. So we always look and see what this middle term is, whatever is to the first power. In this case, it's x squared, and we let something like w equals x squared, so that this becomes w squared minus 9w plus 20 equals 0. And I guess that was the next step here. And then it says solve the quadratic equation for the new variable. Now you can use any technique you want here. In fact, you can either, in this case, factor, as it's not too hard. This is w minus 5 times w minus 4 is equal to 0, in which case w equals 5 or 4. Or you can use quadratic formula, which is pretty typical in these problems, especially when they don't factor well. And you can't always expect them to. So here, w is equal to negative 9. Let me write out the quadratic formula first here. Let's see. Negative b plus or minus the square root of b squared minus 4ac all over 2a, which in this case is negative 9, plus or minus the square root of negative 9 squared minus 4 times 1 times 20 all over 2 times 1, which is 81 plus or minus the square root of 1. Sorry, my bad. 9 plus or minus the square root of 81 minus 80 over 2, which is 9 plus or minus 1 over 2, which is 5 and 4. So we see that we get the same values either way. And you could even complete the square there, although I don't have enough room. So then it says in step 4, substitute back for the original variable. Well, if w equals 5 and our substitution was w equals x squared, then this means that x squared is equal to 5 because w equals x squared, which means that x squared equals 5 implies from the square root property that x is plus or minus the square root of 5. And likewise, if w is equal to 4, then w, which is equal to x squared, is equal to 4, which implies x is plus or minus 2. And I guess, again, I did it a step too early. So then it says solve for the original variable, but I actually already did that up here. So this is x equals plus or minus the square root of 5, or plus or minus 2. Now this next one looks a little bit scarier, but it's not too bad. Again, in this case, what we should note here is that x to the 2/3 can be rewritten as x to the 1/3 squared, which happens to be similar to this power here. This leading power is always twice that middle power, then you're going to have quadratic form. And we're going to let, let's do this here. This implies that x to the 2/3 minus 7x to the 1/3 plus 12 equals 0 is x to the 1/3 squared minus 7 times x to the 1/3 to the first power plus 12 equals 0. So choosing that middle term, that first power variable, even though it's a 1/3, it's got that first power in the linear term, or the linear sense. And so we're going to let w equal x to the 1/3 so that this equation becomes w squared minus 7w to the first power plus 12 equals 0. And we should be able to factor this one as well. I think w minus 3, w minus 4 will do it. And this implies w equals 3 or 4. So if w equals 3, then w, which is equal to x to the 1/3, is equal to 3, which means that x to the 1/3 is equal to 3. Switching back. And now what we have to do is we have to solve for x. And this is easy enough. This is really, what does this really mean? This really means the cubed root of x is equal to 3, so we'll cube both sides. So x is equal to 3 cubed, which is 27. If if w, come on, if w equals 4, then w equals x to the 1/3 equals 4, and that implies that the cube root of x is equal to 4, or x is equal to 4 cubed, which is 64. So x equals 27, or 64. Now this one's a little bit trickier because x here is to the first power. But what you must notice here is 1 is twice 1/2. So what we're going to do is we're going to rewrite this like this. 2x to the first minus 7x to the 1/2 minus 30 can be rewritten as 2 times x to the 1/2 squared, because 1/2 squared is going to give us the first power, minus 7x to the 1/2 to the first power minus 30 equals 0. So I probably don't need to say this. You probably already figured this out, but you really need to be on top of your exponential rules here. Let's see. So we'll let's choose a fun letter. Let's let n equal x to the 1/2. So that this becomes 2n squared minus 7n minus 30 equals 0. Now maybe you can factor that, maybe you can't, but let's go ahead and use the quadratic formula here. But it won't be x equals. It will be n equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which in this case will be negative 7 plus or minus the square root of negative 7 squared minus 4 times 2 times negative 30. Let's make that a little bit clearer. Negative 30 all over 2a, which is 2 times 2, and this will become 7 plus or minus the square root of 49 plus 240 all over 4, which is 7 plus or minus the square root of 289 over 4, which I believe is 7 plus or minus 17 over 4. Although it's been a long time since I rock and roll. Let me double check that. 289 square root. Psh, nailed it. I should teach math probably as a career. Anyway, let's see. That means that this is 7 plus 17 over 4. That looks like garbage. Plus 17 over 4, or 7 minus 17 over 4. Now 7 plus 17 is 24, and 24 over 4 is 6. And then negative 10 over 4 is negative 5/3. So as we undo our substitution here, if n equals 6, remember that n is x to the 1/2 is 6, but x to the 1/2 is the same thing as the square root of x. Excuse me, not 6. Square root of x equals 6, so we're going to have to square both sides here. And what we see is one answer is x is 36. If n is equal to negative 5/3, then n equals x to the 1/2 is equal to negative 5/3, which would suggest that the square root of x equals negative 5/3, which doesn't look like it's going to work out too well since it's a principal square root and it's only going to spit out a positive number. But if we square both sides like thus, it suggests that x is 25 over 9. Now, what we should be doing is checking our answers, especially when we're squaring the results. So let's double check. For x equals 36, we have, using this original equation up here, 2 times 36 minus 7 times 36 to the 1/2 power minus 30 is equal. 2 times 36 is 72. Minus 7 times the square root of 36, which is 6, minus 30 is equal to 72 minus 42 minus 30 equals 0. It sure does. For x equals 25 over 9, we have 2 times 25 over 9 minus 7 times the square root of 25 over 9 minus 30 is equal to 50 over 9 minus 7 times 5/3 minus 30, which is equal to 50 over 9 minus 70 over 9 minus, well, 30 over 1 is going to be 270 over 9, and that is not equal to 0. So we can throw this answer out. We only have one answer. X equals 36. Okay. Solve each equation using substitution. Simplify your answers completely, which is basically what we've been doing. Although these look like they're going to get a little bit harder here. Let's switch colors. Okay. So, in this case we have, if we cut to the chase here, our middle term is x cubed. So we're going to let w equal x cubed so that this becomes 8w squared plus 513w plus 64 equals 0. Now, I don't know if I can factor that. We don't have to. We should be able to use quadratic formula. So W is equal to negative 513 plus or minus the square root of 513 squared minus 4 times 8 times 64, all divided by 2 times 8, which is negative 513 plus or minus the square root of, calculator time, 513 squared is large, minus the quantity 4 times 8 times 64, which should be 4,096. Nope, 2,048. I was off. And the result under the radical is 261, 121, which is probably a perfect square, over 16. Let's see, let's take the square root of that guy. Yep, 511. So this is negative 513 plus or minus 511 over 16, which is either negative 2 over 16 or negative 1024 over 16, which is negative 1/8, or what is that, like 64? 1024 divided by 16. Yeah, negative 64. Now, those aren't our answers. Those are our W's. So, that means either x cubed is equal to negative 1/8 or x cubed is equal to negative 64. So now what we're going to do is we're going to take the cube root of both sides, and we get x is the cube root of negative 1/8, which is negative the cube root of 1 over the cube root of 8, which is negative 1/2. And for taking the cube root of both sides here, we just get x is equal to negative 4. So those are our two answers. X equals negative 1/2 and negative 4. You'll notice in this problem I didn't bother to check my answers, and that's because I had odd powers and odd roots, which deal with negative symbols, negative signs really well, unlike the previous example. All right, let's do one more. Again, we're going to adopt the strategy that we're going to take this middle term, and that's what our substitution is going to be. W is going to be x to the 2/3. So x to the 4/3, that leading term, is really x to the 2/3 squared. So this is 4. Oops, well, that needs to look like a better arrow. X to the 2/3 squared minus 13 times x to the 2/3 to the first power plus 9 equals 0, which, according to our substitution, is 4w squared minus 13w plus 9 equals 0. And if you can factor, that's going to factor as 2w plus 3? No. That's not going to factor like that. Excuse me. Let's see. 4 and 1, no, 2, no. Well, let's use quadratic formula. W is negative 13 plus or minus the square root of negative 13 squared minus 4 times 9 all over 2 times 4, which is 13 plus or minus the square root of 169 minus 72 all over 8. Excuse me, that's not right. 72 is not right. That's 16 times 9, which is 144. Let's double check that. Yeah. Making this 13 plus or minus the square root of 25. Oh, that's nice. Over 8, or 13 plus or minus 5 over 8. 13 minus 5 is 8, so that'll be 8 over 8, which is 1. And 13 plus 5 is 18 over 8, which is 9/4. So those are our W's. That means that either W equals x to the 2/3 is equal to 1, which means that, see, if we rewrite this using rational exponents, this is the cube root of x squared equals 1. So we'll cube both sides. So x squared equals 1 cubed, which is 1. And then we'll take the square root of both sides, which is x is equal to plus or minus the square root of 1, which is plus or minus 1. Alternately, you could have just used the reciprocal power. If x to the 2/3 is equal to 1, then x is equal to 1 to the 3/2, which is plus or minus 1. Excuse me. Or W equals x to the 2/3 is equal to 9/4, which implies that the cube root of x squared is equal to, it's also, by the way, the cube root of x quantity squared, which I like better, is equal to 9/4. So in order to undo that square, we'll take the square root of both sides. This implies that the cube root of x equals plus or minus 3/2, in which case when we cube both sides, we'll get x is equal to plus or minus 27 over 4. So it looks like we have 4 answers. X equals plus or minus 1 or plus or minus 27 over, whoops, that shouldn't be a 4. 27 over 8. Excuse me. And that's going to do it for our guided practice, folks.